All right, so welcome back from the short break, everybody. We're going to proceed with our next working group, focusing on 3D imagery. So as in terms of the previous session, we saw so much lively discussion, so many wonderful questions that came in. So please, in the same spirit, do keep the questions coming. Very, very exciting. So the topic of this session, so we'll take a look at different options. When we think about, we have all these different sensors, all these different platforms for collecting remotely sensed data. And there's all of these different capabilities in terms of how to create accurate representations of outdoor geographic areas, indoor geographic areas in terms of 3D. So we'll take a look again at some of these challenges and opportunities associated with 3D imagery. And in a very similar fashion to our previous session, we have a team of experts. So we'll have an expert from our academic community. So Tommy Jordan from University of Georgia is going to join us. And we'll have a couple of subject matter experts. Again, we'll have folks that are helping with the questions. So Caroline Tyra, Esri, and Lee Brenton from Esri are going to help with some of that discussion and the Q&As that are coming in. And Kira Morish is going to facilitate and to moderate this particular session. Kira is a solution engineer on our smart cities team. Her focus is 3D, and particularly the ArcGIS urban application that we have. And obviously, so, with urban, there's a lot of focus that is being placed on cities in terms of creating sustainable cities, solving problems, and so on. So Kira, we'll let you take it over.
Great, thanks, Jerry. So for this working group, our topic is remote sensing, the foundation for 3D capture and reality mapping, which is exciting in terms of discussing approaches and challenges to integrating these subjects into the curriculum, and in terms of addressing rapidly developing technologies in areas like photogrammetry. And I'm joined today by three experts in the 3D and remote sensing fields, and I'll hand it over to the panel to introduce themselves, starting with Dr. Tommy Jordan.
Hey, everybody, I'm Tommy Jordan, and I'm from the University of Georgia, the Center for Geospatial Research. I'm also past president of the American Society for Photogrammetry and Remote Sensing. I've spent my career working in 3D, starting with the very first spot satellite stereo data, and working through, I'm a drone pilot now, and so I've gone through kind of all of the heartache and experimentation to get 3D from imagery onto our desktops.
And Tommy, I really enjoyed learning about your augmented reality program at the university. That was great.
Yeah, well, that's we've got a pretty good team of smart people working there, so it's with exciting. Lots of good ideas. Yeah.
Okay, and Caroline.
Yep. Hi, Caroline Tyra. I am on Esri's imagery remote sensing team. Long experience in the geospatial community, working with everything from satellite data to drones, lots of different data types: radar, LiDAR, imagery, acoustic. Currently, I report into our Sure software team, which is newly acquired. It's 3D software that creates reconstruction from imagery photogrammetrically.
Caroline, you must have seen just a whole wave of change recently.
Completely.
Yeah.
And I'd love to talk about that too, because we really have moved. There's been a great convergence built on GIS with what was formerly very separate in terms of simulation from game engines to really getting into, bringing CAD and BIM data together. So it's been really fun.
Great, thanks, Caroline. And Lee.
Hi, good day. My name is Lee Brinton. I'm the 3D technical and practice lead for professional services at Esri, and that's our consulting firm. So a lot of the work that I focus on is around 3D GIS. I have a background in remote sensing and also offshore maritime surveying.
Great, thanks, Lee. So to kick off our conversation today, we have a poll with a couple of questions. If we could launch the poll, and if you take a couple of minutes, maybe half a minute, just to take a look at these questions, we'd love to get your feedback. So the first question is centering around the value of 3D data. And then the second question, we're interested in finding out the sources of remote sensing data that you're commonly using at the moment in your courses or your research. And Caroline, based on what we were just talking about, we could probably add a whole bunch more to this list as well.
I particularly like the "it's cool" answer because it is. And I think anybody watching this understands that really the best thing about 3D, whether you understand the source imagery, is that it's immersive. It's the way we as humans view things. I like 2D stuff too, but 3D really is immersive, brings everything into context at a human level. So yeah, it is cool.
I love that. All right, maybe just a couple more seconds here and then we'll take a look at the results. It's funny, Caroline, in the product that I work with, Urban, we're using the integrated mesh a lot more, which is we do it exactly for the reason you just described, because it starts to provide that really immersive experience.
Exactly, Kara. And when we talk about 3D, there's a couple of different disciplines here. And I mentioned gaming engines earlier. So procedural modeling, simulated 3D is robust, and we've got great solutions for that here at Esri. But this is the remote sensing and imagery community. So what we're really seeing is the application of reality capture and real-time data capture being applied over meshes or in point clouds or in true orthomosaics that really it captures the as-built environment and what everything, at least at a point in time, models.
Yeah, I like that. And it helps you see what you might not have noticed before, which is super helpful in the urban environment as well as the natural. Okay, let's have a look at our results here. So the first question, what is the value of having your data in 3D? We have an overwhelming response for better visualization. And then coming in second is better understanding for decision making. So Tommy, I might pass this question over to you to see if you have had a similar experience when you're introducing 3D in your courses and to students' communication and understanding of the content.
Was that a question? I'm sorry.
Yeah, sorry. It's like, do you find that it does give them better understanding, better communication, better visualization?
Yeah, especially like when I'm teaching, for a long time, I taught a geology field school. And by integrating LiDAR and drone point clouds derived from drones, being able to twist those things around and look at them from different angles really help to understand and communicate what these different geological structures are. We taught it out in Colorado, where the geology is absolutely in your face, and much more than Georgia here, where everything's buried, but under trees and dirt, soil, excuse me. But I mean, that using the 3D and the visualization applications to be able to move these things around and see it from different angles really does, and see the context, lines of sight and things like that. It really does improve your ability to communicate what's going on in the landscape. So I like that.
Yeah, I like that too. And it's great for students as well, like just to have that understanding. It's good for, I know a lot of the city customers that we work with, that's enormously beneficial to them to be able to get that increased understanding.
And it's cool.
And it's also cool.
Yeah.
That was the third favorite answer. Okay, and then for what primary sources of remote sensing data, we have a lot of different responses here: LiDAR, drone, DEMs. Tommy, in your courses, do you have a sort of a similar range of data sets that you're using?
We've used all those data sets. I think that today, for the 3D, we're using, like it said that the LiDAR and DEMs were the primary sources. I find that I'm liking more and more higher resolution data these days. And so I'm working with smaller project areas and like higher resolution data. Well, I mean, Georgia, we work on the whole Georgia coast. That's not exactly a small project area, but with a DEM that has a 1 meter vertical resolution or a LiDAR, which has got 6 inches vertical resolution, I would much rather use the higher resolution stuff. And then for smaller feature project areas, the drones give me, I mean, we map gardens, and so we're mapping actually plants and leaves and calculating biomass. And so the 1 millimeter resolution that we can get from a drone from 20 feet is pretty great, you know. So don't use so much stereo satellite data anymore. It's don't really need to, but used to a lot with Spot and Iconos and some of those others.
Is that demand, Caroline, this question's for you, is that demand for the higher resolution? You see that throughout your recent work with the Shore?
Yeah, great question,
products?
Kara. We do because feature extraction is really important, and even down to street level. So if you can get a beautiful 2 centimeter mesh and resolve objects at very high resolution, there's a lot of applications for it in infrastructure, monitoring and management and design, in planning your electric grid, things like that. There's other applications where, okay, sometimes good is good enough and you don't need it as at that extreme level. But we're also finding again that, imagery is playing a really important role in both accuracy, precision in creating some of these 3D models.
Thanks, Caroline. Okay, switching tack now. I'm interested in trying to find out a bit more information about when you're starting, this is to you, Tommy, when you're starting to teach students 3D, what are some of the most effective tools you have to introduce them to some of the concepts?
Probably I should start with LiDAR talking, because that's the most in your face and easy kind of a 3D data set. It's automatically 3-dimensional. And we have good LiDAR over the county that I live in and over the campus. So if I can bring, I'll give them a subset of a LiDAR data set, a couple of tiles, and we'll look at it in a tool like Quick Terrain Reader, which is a free visualizing tool. And just let them scan around and fly through and create videos and whatnot. Show them what 3D does, and then we'll, show them how it's created. Talk to them about LiDAR and how it's done, and then move from there into the photogrammetry and the point cloud derivation from drone imagery. And we'll actually take them out and collect some data or give them some canned data. Sometimes we let them collect data, from handheld photographs of like small things like cemetery monuments or statues or rocks or hillsides or something like that, and let them create their own 3D data from that.
Got it. Thanks, Tommy. And Lee, I know you do a lot of education as well and introduction to 3D. Do you have any specific tools or workflows that you use?
Yeah, mostly we focus our efforts around utilizing LiDAR. And most often I have been using, we find that the 3D base map solution, which is a free download for ArcGIS, is something that's really useful. It really starts to give our audience or the students a foundation around ArcGIS and what can we do in 3D. It utilizes LiDAR, and it's kind of framed around a tutorial-based program. It doesn't just get them familiar with visualizing in 3D, but it also allows them to get their hands on some analytics, things like feeding this into an urban planning workflow or doing some shadow impact, solar radiation. These are all hot topics for a lot of our students, and same with flood impact. So rather than it just being a cool image, it starts to become a usable representation for analysis. And the really nice thing about the 3D base map solution is that it's essentially a guided workflow that you can walk through. And I use this often for a lot of the courses that I teach to get people ramped up on 3D.
Could I ask a question to you, Lee?
Yeah, absolutely.
I'm not familiar with these 3D base maps. Does it give you an opportunity? It says foundational workflows, and so does it come with data, or does it
Yep.
allow you to?
Yeah, it actually comes with data. It comes with LiDAR, building footprints. It walks you through. It has documentation and everything. You can go from start to finish and have data published onto the web that's 3D, and then also your analytical results. So it's the full workflow.
And can you actually plug your own data into this once you understand how the workflow works?
Yeah, and that's really interesting because I work mostly on our consulting side of Esri's company, and we use this in-house as well to do data production for customers. So if you would like to do some data production for your university campus or the city that the university is in, you can get the access to the LiDAR and feed this directly into the tool sets. And what it's really doing is simplifying a lot of the traditional step-by-step analytics that one would need to go through to create content, like digital elevation models and extracting footprints and finding those footprints and things like that. And it's really simplifying it through some back-end Python scripts that we've prepared. The user doesn't need to know Python, they just need to walk through the steps and go through each procedure.
So in an educational environment, I mean, we need to know we need to be able to teach the students how to do this building extractions and getting rid of the vegetation layers and being able to process all of the LiDAR. Would you start with something like this workflow and then work backwards and saying, okay, so now here's how you actually build the components of this thing?
100%, yeah. So this will give a very basic foundation of how to do this work, and it gives the students some fundamental understanding of what is an elevation model, what's the difference between a digital surface model, a digital terrain model, and then how do I normalize those things, and what is a normalized digital surface model, and why would those things be useful to me? Once you have that basic understanding, the Python scripts are actually publicly available, and you can crack them open if you wanted to and start to dissect them. Or you could start to look at individual tools that the tasks are calling and look at them in more detail. So you can start to modify it a little bit.
Very cool. Very cool. Thank you.
Yeah, no worries. Trying to get out of my.
Great. And that's a tool we use all the time as well to create the 3D context. Very handy. Okay, we have some questions coming in from the Q&A. So this first one, I'm just going to open it up to the panel, and feel free, whoever would like to jump in on this one. It's from George, and he's asking, can you give a brief rundown of any experience anyone has in the use of digital twins for asset management and planning?
That is a really broad topic, to say the least.
So, George, feel free to narrow it down if you like.
All right. Over to you, Caroline.
Not something I can do in the space we have here. We've got a lot of really great blog posts from both our 3D team with the City Engine GML. Shore is getting involved in that space as well. And we've got this crack AEC team who are also applying principles of digital twins every day. So there's a lot of material to point you to. I'd be happy to do that separately. But again, the science of where really means that GIS is a foundation for all of this good stuff. And so we're definitely in the space and doing a lot of work there.
To kind of extend what Caroline's describing, that is a really broad question. However, what I like to how I like to approach it is understanding if the target is to have what I consider a static representation, which some people consider as a digital twin or like a static diorama of an urban space, if that's the digital twin target. Or are you interested in tying smart devices to the three-dimensional representation? So have an IoT really tied in, and then understanding what is going to be tied in and how are those backend systems going to interface with your 3D representation of that. We see this often with ports and cities and counties where maybe not all of the assets that they're working with are visible. So that's where 3D really starts to jump out as being useful. It gives you another avenue into visualizing content that on the street or the proverbial street that you wouldn't be able to see with the naked eye. Things that are underground, underwater, inside walls, things like that. But it becomes a really big task to think about.
Thank you both for helping with that question. Very good. Tommy, from what you've heard from Caroline and some of the new data sets available and from Lee, is there a decision-making process that you have to go through before you start to think about adopting some of these new technologies in terms of teaching students and exposing them to more 3D visualization and analysis?
You know, one of the problems in teaching 3D GIS is that, especially at an undergraduate level, it doesn't really happen. We're focused, there's not really room in the curriculum for more than just maybe a lecture. The focus is on 2D, learning the foundations and how to, operate the software and all that. And so most of the 3D comes in as a graduate student seminar, master's and PhD levels, or as individual students are interested. So then it comes down to what are the problems that you want to solve, and every problem that you want to solve and the scale at which you need to solve it, kind of points you to a different kind of data, or what is the most appropriate thing to do. I mean, if you're trying to map gully erosion from a there's the words are being transcribed, and it says it's underneath there. It says you want to belly erosion, which is kind of funny, but gully erosion, you've got different scales, gully erosion or landslides, which is what do you want to care about? And so you might use a drone, you might use handheld photography. You might use a drone at 400 feet, or you might use a drone at 50 feet. Or if you have LiDAR available, then you can do that. I mean, coastal erosion is a big deal for us, and also wetland stuff. And so the drone is going to be the only way you can really do that, because you can time your drone flight for low tide or any particular time of year, spring tides, or however it happens to be. And so it gives you a lot of flexibility to that. So the answer to your question is it's complicated. It really depends on the problem that you want to solve. Somebody I saw in one of the questions, somebody had asked about INSAR, and radar is, from satellites, that's a really big area that you're dealing with. And I don't really do that anymore so much. Like I said, I'm more interested in the higher resolution solutions, but there again, the INSAR might be completely appropriate if you're dealing with an oil field in Canada or something like that, where you want the big picture for it.
I guess that comes back to the idea of teaching students how to not just the tools themselves, but what problem they're addressing, how to use the right tools to get the most appropriate answer or the most accurate answer.
And really, what are the characteristics of the different data sets? Because they all have different, we've talked about accuracies, we've talked about resolutions, we've talked about, weather conditions of the things. Oh, I don't know, we did talk about weather, but, you can't fly a drone in the rain, but you can get radar in the rain. So, or through the cloud, whatever, but just the different characteristics of the data and what they're really well suited for. And so that's all.
That makes perfect sense. Lee, I expect you find that as well in the consulting
Yeah.
side.
Yeah, I like to really have a good understanding and also try to get the end user to have a good understanding of what their goal is. I have a saying that usually the highest resolution data is not the best for all applications. It's good to understand what is the lowest level of detail needed to do the task at hand. If it's something about urban planning, I don't necessarily need to see every single window on all of the buildings throughout the cityscape. I just need to understand what are the buildings around and what are the general shapes. And that also comes with a large cost. So if you think about how much time and money and effort it goes into creating a hyper realistic representation of the real world, it can be a lot. And is it really necessary for the task at hand? If I want to just understand shadow or flooding and how the flood will impact a specific city. So having a good understanding and a really realistic understanding of what your task is key.
Yeah,
Totally agree with that, Lee. The cost is at higher resolution stuff gets more expensive, and do you really need to spend that much money on it?
Yeah, exactly.
that much processing time.
Yeah, well, that's money too, right?
Yeah, that's true. That's very true. So Tommy, with your virtual augmented reality course, is there plans to expand that? What are your thoughts on the future here in the last couple of minutes that we have?
Well, I'm not really involved in that particular thing. Marguerite gives me credit for it, but we're integrating more and more into it. We've got we've got goggles, and people are creating. We have students who are creating apps which superimpose, the outside world with virtual imagery. We're actually working in some cases with historical imagery so that we can look at a location today, and then with our iPhones, we look up with our phone and we see, well, I can't see my phone, there it is, and you can see that an historical image as to what it looked like 100 years ago, and things like that. And so using that to understand cultural GIS or locations, and then is really an incredible way of being able to teach and learn. And then with the 3D goggles, it's fully immersive, and that's pretty it's pretty confusing to me anyway. So I haven't done it a lot.
You're supposed to say cool. That's the key.
Oh yeah, it's very, very cool. It's really cool. No, it is that. You can say that without any equivocation at all.
All right. And Justin, we've got one more minute. Lee, we had a quick question in the chat window about that 3D base map solution is not just for the US, right? That's for...
Yeah, so the 3D base map solution is for anyone who has access to ArcGIS Pro. Anyone can use it. It could be used as long as you have LiDAR data. It also comes with LiDAR data, so if you don't, you can just go through the process of creating the data with the provided tutorial data. We do have base map content outside of the US, if that's something that you're interested in, but usually that is shared based on the end client's permission. So you'd have to look for that. Yeah.
Great, thanks Lee, and thanks Tommy and Caroline. And thanks everyone for attending. We're going to be having a 5-minute break now, and then we'll start back with the third working group.